suppose a particle moves from point A, say this is point A, to point B, say this is point B, and then from B to point C. What's the total displacement vector? This brings us to the idea of how do we combine vectors. Well, the total displacement vector is really saying how far or where did this particle end up relative to where it started. Well, the displacement vector is going to be the same as the vector AC. So the particle moved from A to C. So the displacement vector is in fact AC. That's the total displacement, not the total distance it traveled. Because if it actually went from here to here, it traveled farther than simply vector AC, but the displacement was equal to AC. Now, this brings up the idea of vector addition. If U and V are vectors, and again, hopefully you can see those are bold type. All these are vectors here. I'm going to stick those arrows up there just to make sure for now until you get used to this idea that those are all vectors. If U and V are vectors positioned such that the initial point of V is a terminal point of U, then the sum U plus V is a vector from the initial point of U to the terminal point of V. Well, that's exactly what I have here. If this is vector, let me see, initial point of view. So if this is vector U, see the terminal point of view is going to be the initial point of V. Then this is actually U plus V. This vector earlier that I called, that I made reference to as being AC. So you may notice here that I can draw this thing out. Let's see, how do I want to do this? This is actually referred to as the triangle law. And let me go ahead and draw this out again real quickly here. You can obviously see from up here that this is a triangle. But if this is U, so here's my initial point of view, my end point, or my the tail and the head and the tail of U, and then here's my initial point of V, which is the tail end of U. Then what this does is this makes a triangle, and this is actually U plus V. Now consider two vectors, U and V, and I want to find U plus V and V plus U. Again, just for notation here earlier, or clarification early on this topic, I'm going to put those arrows there. This introduces the idea of the parallelogram law. So let's see here. I'm going to take, I'll go ahead and leave that there. I'm going to take U, and let's see, this is going to be vector U. And then I'm going to take vector V. And what I want to do with this vector V is obviously I want to take this thing, and when I add it, I want to move it over like that. And then what I end up with is, when I add those two, is I end up with this right here. This is U plus V. But what if I were to add them in the other direction? So let's take this, whoops. See if I can grab this vector here. Here's U, and here's V again. Oops, let me see here if I can't grab this. So what if I take V and I add it to U? If I do that, then what I end up with is this vector as being V plus U. And what I'm going to claim is, if I can grab these properly, let me see if I can just move these over. If I move this over to here, and I move this over to here, see what I have is the exact same vector. U plus V is V plus U. That was kind of messy the way I wrote that, but you can see that's V plus U. Let's go ahead and just erase that. And I'm going to put this back. And then this bottom one, again, I'm just going to repeat this. This is V plus U. See what happens is if I take U and then add to V, then V and add it to U, put them together, I end up with this parallelogram, hence the parallelogram law. And this is confirming that U plus V is in fact equal to V plus U.